Hi, dear grade 7 students. Welcome back to our science class. Get ready with the following materials. Your interactive science textbook, copybook, workbook, pen or pencil, highlighter, earphone. Are you ready for the lesson? Then get ready with the science textbook pages 464 to 469. Chapter 12, Earthquakes. Lesson number 3, Monitoring Earthquakes. Our lesson objectives: explain how seismograph work. Explain the patterns that seismographic data reveal. New words in this lesson: seismograph, ring of fire. Now let us to check the review for the lesson. Look at the diagram. You can see a seismograph. How a seismograph works. What is a seismogram? What patterns do seismographic data reveals? Primary waves, secondary waves, surface waves. And finally, you can see a map. The different colors indicate that the highest and least earthquake regions. Let us to check our first objectives. How do seismograph work? The mechanism of a seismograph. Look at the diagram. A simple seismograph. It consists of a heavy weight attached to a frame by a spring or wire. A pin connected to the weight rests its point on a drum that can rotate. As the drum rotates, the pen in effect draws a straight line on paper wrapped tightly around the drum. Seismic waves cause a simple seismograph drum to vibrate, which in turn causes the pen to record the drum's vibrations. The suspended weight with the pen attached moves very little. This allows the pen to stay in place and record the drum's vibrations. Measuring seismic waves. In a seismograph, it's the pen that remains stationary while the paper moves. Why is this? Anybody can answer? All seismographs make use of the basic principles of physics. Whether it's moving or at rest, every object resists any change to its motion. A seismograph's heavy weight resists motion during an earthquake, but the rest of the seismograph is anchored to the ground and vibrates when seismic waves arrive. We can check different types of seismograph: vertical seismograph, horizontal seismograph, modern seismograph. Look at the diagram. You can see how the different types of seismographs look like. Now let us to check Reading a seismogram. You have probably seen the zigzagging lines used to represent an earthquake. The patterns of lines called a seismogram. That zigzagging lines are called seismogram. Look at the diagram. You can see the seismogram. Is the record of an earthquake's seismic waves produced by a seismograph. Study the seismogram in figure. Notice when the primary waves and secondary waves and surface waves arrive. The height of the lines drawn by the seismograph is greater for a more severe earthquake or an earthquake closer to the seismograph. Now we can check seismograms. When an earthquake's seismic waves reach a simple seismograph, the seismograph's drum vibrates. The vibrations are recorded by the seismograph pen, producing a seismogram as shown in the diagram. Look at the diagram. You can see few zigzag lines. The first zigzag line is called the primary waves. P waves travel fastest and arrive first. The second zigzag line indicates that secondary waves. The S waves arrive shortly after primary waves. Finally, you can see the highest disturbance on the seismogram. It indicates surface waves produce the largest disturbance on the seismogram. Now let us to check our second objective. What patterns do seismographic data reveal? Geologists use the seismograph to monitor earthquakes. Other devices that geologists use to detect slight motions along faults. Even with data from many different devices, geologists cannot yet predict when and where an earthquake might strike. But from past seismographic data, geologists have created maps of where earthquakes occur around the world. The maps shows that earthquakes often occur along plate boundaries. Where plates meet, plates movement stores energy in rocks that makes up the crust. This energy is eventually released in an earthquake. Earthquake risk in North America. Earthquake risk largely depends on how close a given location is to a plate boundary. In the United States, two plates meet along the Pacific coast in California, Washington State, and Alaska, causing many faults. Frequent earthquakes occur in California, where the Pacific Plate and North American plates meet along the San Andreas Fault. In Washington, earthquakes result from the subduction of the John D. Fuca Plate beneath the North American plates. During the subduction, one plate is forced down under North Plate. Look at the diagram. You can see the different plates, San Andreas Fault and North American plates. Earthquake risk around the world. Many of the world's earthquakes occur in a vast area of geologic activity called the Ring of Fire. In this area, plate boundaries form a ring around the Pacific Ocean. Volcanoes as well as earthquakes are common along these boundaries. The Ring of Fire includes the west coast of the Central America and the west coast of the South America. Strong earthquakes have occurred in countries along these coasts where plates converge. Across the Pacific Ocean, the Pacific plate collides with several other plates. Here Japan, Indonesia, New Zealand and New Guinea are the seismically very active. India, China and Pakistan also have been struck by large earthquakes. In this area of the world, the Indo-Australian plate collides with the Euro-Asian plate. Earthquakes are also common where the Eurasian plate meet the Arabian plate and African plate. Now let us to check our diagram. Earthquake risk around the world. Why do earthquakes occur more often in some places than in others? Earthquakes are closely linked to plate tectonics. The map shows where past earthquakes have occurred in relation to plate boundaries. Look at the diagram. You can see some star marks and X marks and red color lines. The stars are close to plate boundaries. Many earthquakes are here. The X marks indicate that it's lie far from the plate boundaries. Fewer earthquakes are here. The red lines, it indicate ring of fire around the Pacific Ocean. Let us to summarize our lesson. What is a seismograph? A seismograph is an instrument used to detect and record earthquakes. Mechanism of a seismograph. Generally, it consists of a mass attached to a fixed base. During an earthquake, the base moves and the mass does not. The motion of the base with respect to the mass is commonly transformed into an electrical voltage. Seismic waves cause a simple seismograph drum to vibrate, which in turn cause the pen to record the drum's vibrations. But from the past seismographic data, geologists have created maps of where earthquakes occur around the world. The maps shows that earthquakes often occur along the plate boundaries. What is the Ring of Fire? It is a major area in the basin of the Pacific Ocean where many earthquakes and volcanic eruptions occur. Now let us to check few questions from this lesson. What is a seismograph? Describe the working of a seismograph. What patterns do seismographic data reveal? Define the term Ring of Fire. Why do earthquakes occur more often in some places than others? Now let us to wind up our lesson. You have some follow-up activities. Log in the pearsonrealize.com. Do the monitoring earthquakes enrich? And the lesson quiz. I hope that you learn and enjoy from this video. Thank you for watching my video. Good luck. See you. Bye bye.